Hello friends, my name is Akshay. Today's task is to solve GFG daily practice problem. So our today's problem is delete node in AVL tree. So we have a given AVL tree and here is learn what is AVL tree do. So here we have node. In node we have data and height. So data stores the values and height stores the height of the node, and left and right pointers which needy, and then data, and when node is created so it height will 1. Okay, so it's okay, and left and right is null. So here set height function is here, and then build tree. This is algorithm for tree building, and yes, this algorithm is for checking is BST or not. Okay, and here is balanced. Okay, so we don't need to look it. Here we have create algorithm for deleting node. So let's start. First of all we have to find height of the node. So int height node star root. Okay, if root equal to null, then height will be 0. Okay, else GST. Okay, so that variable height is given here. Okay, so this function will give height of the root. Okay, and another function is first of all we can find height for doing this, but what if when we want to find balance factor of any node? So int get balance factor node star root. Okay, and then if root equal to null, then balance factor also 0. Okay, else return height of root left minus height of root right. Which we know balance factor is a height of left tree minus height of right subtree of any node. It is balance factor, because when we delete node, so we check the balance factor of the node which are remaining. It is minus 1 or 0, must be minus 1, 1 and 0. If it is not, so we have do some rotations. So we have 4 rotation: left left, right right, left right, and right left rotation. So here we first create right rotation. Okay, so for creating right rotation we have give pointer. So node star right rotate. I used camel case. Here we have to give node. Okay, so we take one pointer node star temp, which is pointing to here is right rotation. So left, so vice left child we want. So here left, and then node star another variable for temp store temps right. Okay, and right is equal to y. Okay, and y left is equal to t. Okay, so here we can see that we have one node and its left child is stores in temp, and then temp's right child is stores in y. So temp right is equal to y. Okay, because first of all y is a root, but when you tell temp is a left of root, and then t is a left of root and right child, so temp right is equal to y. It means temp will be root and y will be right child of temp, and right child of left of root, so it's left of roots right. Okay, so here our code is complete for rotating right side, and here we have to update height of y. So y height HT is equal to max of height left or plus 1. Okay, and we have to update height of temp. So our right rotation is complete. So like this I create our left rotation. Here we have to store one y's right in temp, and then another t which stores temp's left, and then temp left is equal to y, and then y's right is equal to t. It is very easy to understand. Okay, so here we have to update again y and temp, so I copy it from here. So this is completed. Okay, so this is a basic function which need for deleting a node. So first of all we want get balance, and another function is mean value. We want to predecessor for deleting node. So for doing this, here we write mean value function, node star mean value node, and here we have to give node. Okay, we take one current pointer which stores the node, and while current left does not equal to null. current equal to current left and return current. So how this code will work? So if assume you have a node is given, so the minimum value of from this node, so it will be left side because this is a AVL tree, and in AVL tree we have binary search tree also. So binary search tree's left element is minimum of the whole tree. So we travel to left side of the given tree and then return the current. Okay, so this is a minimum value of the tree. So let's start our first code of delete node. So node star delete node, which is the name of the function. Okay, and node star root is given int key, we take a key. So here we can see in main method it will here call the function delete node, and within it gives us a root and the element. Okay, so here I take a element as a key, and here is our root node. Okay, so if root equal to null, then return root. Okay, if key is less than root data, so root left is equal to delete node root left with key, and like this here, as if whenever key is more than root data, so we have to travel right side because right side is a maximum value. Okay, so it is completed. And when key is equal to root, so here we have to write our logic. Okay, so we have three cases. First case is delete leaf node, and then delete any internal node which have one child or which have two child. So first of all we consider node is leaf node. So how can we know? So its left child and right child will be null. So here we give condition root left is equal to null and root right is equal to null. Okay, so here I create one temp variable t, root left, here spelling mistake, root, if root left is null, so it will give root left, root right. So here we have to use root left and then here root right. Okay, and then check if temp is null, so it means given node is no child, so temp is equal to root and root is equal to null. Okay, and here else when temp is not null, so it have child root is equal to temp. Okay, and free the temp, so here our this if is and else. here node star temp is equal to mean value node. Okay, first check function, yes, mean value node. Okay, so why we find this? Because we find to successor of temp, node successor, but it's before the in order printing node we want to find, so here we write mean value. Okay, so here we want to predecessor, so root right a successor. So if 5 4, assume this is a given, so here our temp is 5, so we find 6, which is a predecessor of 5. Okay, so doing this we can find it, and then root data is equal to temp data, and root right is equal to delete node root right and temp key, here not key but data. Okay, so this is very simple code. Here our code is completed, but before completing this we have to check if root is equal to null. So for we have to check our tree is balanced or not, so we have created left rotate and right rotate function. So using this we balance our available tree. So first check if root is null, then return root. Okay, and we have to update also root height. So for doing this we have to find roots right subtree height and roots left subtree height, and maximum of both it is and plus 1 is it height of our root. Int balance, in balance variable we stores the get balance, we store the balance and factor. This is our balance factor of root. Finding balance factor, so check the get balance name is function or not. We created this function, so yes, here is get balance name of the function. Yes, get balance. Okay, so it giving us a balancing factor of a root node, and assume if balance factor is more than 1, so we need right if balancing factor is 1, so it means our left side tree is big and right side is a small subtree, so we have to use right rotation, and for doing this we have to check left balance is it is more than 0, so we have to do right rotation. Of root. Okay, another condition is if balance factor is 1 and then get balance of root left is less than 0, it means we have to need right left rotation. Or left right rotation. So root left is equal to left rotate root left and return right rotate of root right of root. Okay, if balance is less than 1 and within it get balance of root, if balancing factor is less than 1, so not less than 1 but less than minus 1, because if it is less than minus 1, so it means we need to give right rotation, not right but left rotation we have to. So for left rotation our balancing factor of right subtree have less than or equal to 0. So check this condition, is less than equal to 0. If it is less than equal to 0, then return left rotation of root. Okay, so it is very easy to understand. Balancing factor is less than minus 1 and then get balance of right side is less than equal to 0, so it means it is left rotation. But what if when balancing factor is less than minus 1 and our balance factor of root here we have to give right. Root right is more than 0, so is it right left rotation? Okay, so root right is equal to right rotate and then return left rotate of root. Okay, and at end return root. So our code is completed. So just first compile the code. Here one error in line number 234. Okay, so check it. Where is 234? Here we declare t and we do operation on temp, so here we rewrite our variables name. Okay, and compile. Okay, so our code is true and then submit. Yes, our code is successfully working and all 1110 cases will be passed this code. So this is very simple code. You can do this by yourself and applying your logic and concept. This is a very easy to understanding code. Okay, so bye, and like and subscribe my channel for watching like these videos. And if I can continue solve the question of GFG, so I will upload it videos daily. Okay, so bye.